get started. Turn my microphone off. Today we'll do the reproductive system. And we'll start with male repro anatomy. Let's see, turn this down a little bit. Okay. And I wanted to start with the development of the external genitalia, starting when it's sexually indifferent. So you can't tell what it's going to develop into, male or female. So what they highlight there, call this development of the external genitalia. You got the genital tubercle. And then you have the urethral folds in pink. And then you have the labial scrotal swelling in yellow. Talks about 5 weeks. If it's the male pathway, if they have the XY chromosome inheritance, so males are XY, meaning you inherited the Y chromosome from dad and X from mom. That pathway shows that the genital tubercle becomes the gland's penis. It shows that the urethral folds, they fuse and they form the ventral penis. And then you have the scrotum that forms from the labial scrotal swelling. This is a little outpouching for the gonads, which will descend. This next slide shows if it were female inheritance, X from mom, X from dad, biological sex, male and female, we teach them both. And the gland's penis becomes the gland's clitoris in females. The urethral folds, as you can see, they kind of remain open for the vaginal orifice. And then the scrotum become the labia majora. The labial scrotal swelling become scrotum in males, labia majora in females. So it's a simple couple of figures to get you to see that there are sex differences between the two biological sexes. And so one slide, this shows the adult structures. And so that's what we're going to study today, but just for the male. But just to show you one contrast, know the vulval spongiosus muscle. because in males, that muscle, as you can see, the red arrow is pointing to it. It's pointing to the muscle part that forms the ventral penis. So in males, that muscle is closed, but it remains open in the females. So I just want to give you one difference between the sexes. My mic down just a little bit. All right, so one of the developmental things that's also different between males and females are the gonads. In the females, the ovaries will remain in the pelvic cavity, but in the males, they will start to descend at about 7 months. So that's what this figure is showing us. So I'm going to erase the board here. So if you look at the top, it shows the testes, which are the gonads in males. They're located in the posterior ab wall. And as you can see, at around 7 to 8 months, they start to descend. Now their descent, they don't go down there by themselves. There's a structure that pulls it, and it's called the gubernaculum. It's a connective tissue structure. The gubernaculum will pull the gonad down through a space called the inguinal canal into the scrotum. Gubernaculum pulls testes down through the inguinal canal into the scrotum. That's basically what I said. We'll study the inguinal canal. This canal is kind of a pathway in and out of the body cavity, and it's important to know the male gonads are exterior to the abdominal cavity, and it's a little cooler outside the body cavity, and that's more suitable for the spermatogenesis process. This is where the sperm develop in the testes. The sperm is the male contribution to reproduction. One anatomy detail. Notice as you pull the testes down, it's covered in front by the peritoneum. Okay. So imagine there is a big bed sheet in front of me on the testes. But as I'm being pulled down, I grab onto the bed sheet and I pull the bed sheet down with me. In this case, the peritoneum. And it's pulled all the way down into the scrotum, covering the anterior aspect of the testes. It breaks off. And that pink double layer is known as the tunica vaginalis. And it's one of the coverings of the scrotum. And because it was only covering me on the front, this sheath is a covering for the testes only on the front, basically, not all the way around. So we should know the tunica vaginalis. So what I'm writing is parietal peritoneum is pulled down with testes. piece pinches off and forms tunica vaginalis. So what we learned is, men have a vagina too. Tunica vaginalis. Vagina is a word that means sheath. Okay, so this is a sheath that covers the testes. And so another anatomy thing is inguinal canal, tunica vaginalis. I try to underline the anatomy structures in this lecture because that's basically what this first lecture is, the anatomy, not the physiology. So when we get to the adult structure, it's useful to study a sagittal section. And so what I did was I put all the basic pictures here that are good to introduce the system. Now when you cut right down the middle in the pelvis, you cut right between the two testes. So I put testes in, so at least you could see one included. There's the epididymis that covers it. So anyways, that's why that's there. Most of the time we'll be talking about all the structures in here. I put this picture in too, which we'll look closely at later, because I did mention doing inguinal canal. Because the gonad is outside the body cavity, it needs a lifeline. Blood supply, nerves, the duct, to go in and out of the body cavity. And that's the inguinal canal. And so that picture here kind of shows it dissected open so you can see how structures enter and exit the scrotum. Okay. So a good overview for the male repro. Or what is called the 3 E's. The whole goal is to teach students how do humans reproduce, right? So, we got to consider the female and then the male. So for male contribution for reproduction, the 3 E's are erection, emission, ejaculation. So we'll go over the details throughout the lecture, but to define each one. Erection it's when the penis becomes engorged with blood. For that to happen, the blood vessels, the arteries, need to vasodilate. So think of erection as a vasodilation event. That means arteries open up, blood rushes in. That's an erection. Okay. Now, on all those drugs that we see commercials for, Levitra, Cialis, Viagra, any of them. Okay. The legit ones work by increasing the level of a second messenger. I believe it's cyclic GMP. Well, anyways, the key molecule is nitric oxide, NO. Okay. So that's kind of a bit of physiology of how blood vessels dilate alone for an erection. Okay. And that's why those drugs can help men with erectile dysfunction. It restores that molecule. And so we're going to learn, when I get into the details, the erectile bodies. Well, I don't want to mention them now, it's too much. But you can kind of see all the blue tissue there. We'll study those. Those are the erectile bodies that become engorged with blood. So that's an erection. That's the first thing that must happen. And in the male sex act, you also must have emission. So you got to move the sperm up to the urethra. That's emission. of sperm up to the urethra. Now, even lay people off the street know where sperm are made right there in the seminiferous tubules, okay? You know they're in the testes. You gotta go from there, look where I'm gonna point, right? Boom, there. So you can get from there, outside the body cavity, all the way to there. It's a long journey, and we call that the male duct system, and I'll go through it, okay? But that's the mission, get from there to there. That's the urethra, and then ejaculation is movement of sperm out of the urethra. Ejaculation, movement of sperm out of the urethra and into the female reproductive tract. And since I already mentioned the bulbal spongiosis, that's one of the things that provides the expulsive force for ejaculation. Bulbospongiosis muscle provides the expulsive force of ejaculation. I mentioned that the bulbal spongiosis, just think of this. Bulbo refers to the bulb of the penis at the root. And it covers, it's a muscle that covers the ventral aspect of the penis is right here. Here's that muscle covering the bottom of the penis there. So to move on from this kind of overview, to go over the details, I want to show you that I took a picture of a model that we have in the classroom, because that's what you'll be tested on for the lab practical. And I always like to put the picture from the book, and you know, this book, that's what I use primarily to teach anatomy in this class, because this picture looks a lot like the model in the room, which is sitting on that shelf right there. We won't have time to study models today because we have a test, but we will starting Friday. And I want you to know that you can study pictures in the atlas to help you learn the models when you come to class, you're prepared. Well, one of the first topics I want to tackle are the details of what the inguinal canal is. I want to look at pictures that kind of dissect it. And in doing so, we're going to look what's inside the spermatocord. I said that's the lifeline to the testes, which are outside the body cavity, right there, or in the model down here. And so I have all these little pictures from the atlas that dissect all the way down to the muscle layers of the abdominal wall in the inguinal region. Okay. So this is studying the inguinal canal. Just think of, you know what a canal is, just think of this as a canal in the groin region through 3 layers of ab wall muscle. That's pretty much what it is. Quote unquote canal through 3 layers of ab wall muscle. Just to describe it very simply, okay? Now, when we dissect down to the outermost layer, that's the external abdominal oblique. That's the name of the muscle. But I want you to pay attention to the groin region here and look at the opening that's medial. It's called the superficial inguinal ring, the opening for the spermatocord to exit the body cavity and get into the scrotum. So you have an opening, the superficial inguinal ring. Usually that's kind of where one of the spots a physician will check for a hernia. Like if you're an athlete, you have to get a physical. That's one of the things they'll check for is a hernia. Basically, if you don't know, a hernia is a blowout. When you have weakness, your ab wall ruptures and your intestines a loop of intestine spills out. It'll go through the path of least resistance. Usually it's around this area, around this opening. Okay, that's kind of a clinical side note. You don't have to know a hernia. It's not germane to reproduction, but in this region is clinically significant. You should also know that there are connective tissue fibers from this muscle layer that help form a sheath around the spermatocord and testes, and it's called the external spermatic fascia. Fibers, I'll say fibers from this layer form the external spermatic fascia. External spermatic fascia. They don't really show that later here, but we will see it in other pictures. Now in the next shot, if you dissect away external oblique and get a look at internal oblique, that's this picture here. Internal abdominal oblique. What you can see from this picture, I think they do a good job of showing us that muscle fibers from this layer form what's called the cremaster muscle around the spermatocord and testes. Muscle fibers from this layer form cremaster. So far we got two layers, external spermatic fascia, cremaster, which is muscle fibers. And if you dissect another layer away, we get to the deepest layer of ab wall. That is the transversus abdominis. Okay, there's some connective tissue fibers, the gray, that form, well, the term here is transversalis fascia. So from this layer, the transversalis fascia, they form the internal spermatic fascia around the spermatocord and testes. So the muscle layer is called transversus abdominis, but within that layer is a transversalis fascia form the internal spermatic fascia. Okay, so that's the third layer there. We went from outer to inner. So I want you to know which ab wall layers help form these coverings around the spermatocord / testes. And so tie ice is just a little, well, let me tell you what I mean by that. T, transversus abdominis, I, E, for the muscle layers. And, well, ICE is basically internal spermatic fascia, cremaster, the idea is know which layers came from which ab wall. Okay. So this is the way in and out of the body cavity. Now, also identify the two rings, the superficial one. Superficial is a relative term. The opposite is deep. So that ring symbolizes where the deep inguinal ring is. It's through that deepest layer. So I should add that to transversus abdominis. Be able to identify another opening, the inner opening, deep inguinal ring. Now this picture shows all three layers of ab wall and all three layers of the covering of the spermatocord. They don't show the testes in this picture. This is the external oblique, that's internal transversus abdominis. Going from outer to inner, there's external spermatic fascia. And the artwork's good enough, you can tell that's deeper, right? That's cremaster. And that's internal spermatic fascia. And then they cut it all the way open so you can see the structures inside that cord on that picture. So that's a good one to look at, included in this one here. And if you study a model, the inguinal canal is shown right there. Okay, so from a superior view, it's right there. So you can see it dissected open on our models. And it's good to look at pictures that have the spermatocord and its contents labeled, like that picture I showed you at the beginning, right here. So let's just kind of talk about everything that's in there. So the inguinal canal, this is a passageway for the spermatocord. So let's just talk about what's in the spermatocord. So males need a spermatocord, again, because the testes are outside the body cavity. So that hadn't been said. Do females need a spermatocord? Well, no. They have a ligament. It's called the round ligament. They don't need arteries and veins and nerves and a duct to go to the gonad because it's not outside the body, it's inside the body. So for the male, you have the spermatic cord contents. And for most structures, the most important thing to keep anything alive is the blood supply. So that would be the testicular artery. So little a is my shorthand for artery. And what you can do is you can see that the testicular artery is a branch off the abdominal aorta. So that's why I included this picture there. I want you to know what it branches off of. Branch off of the abdominal aorta. So blood flows down to the testes, okay? And the testicular veins drain the blood in the opposite direction. So these blood vessels, arteries and veins, they're always together, but blood is flowing in opposite directions. So you can either call them testicular veins. VV is, veins plural. Okay. It's also known as the pampiniform plexus. So there's one testicular artery, many testicular veins. I think it's useful to know that the reason why there's many veins and one artery, you want the many veins to cool off the hot arterial blood. Okay, so this is kind of counter-current exchange. So if you have the artery, blood is flowing down to the testicles, to the testes, it's a little bit too warm. And then so if you have testicular veins that surround the arteries, blood is flowing back, it's a little cooler. Okay? There's some heat that's dissipated from the artery to the veins. This helps cool the blood, which is better for spermatogenesis. So let me write that over here. So I'll just say that the many veins, you cool the arterial blood, okay? The other thing that's in there, there's other things like nerves and lymphatics. I'll just give you the most important thing, okay? That is the vas deferens, the structure that carries the sperm, or ductus deferens. Ductus deferens. Sometimes I still use the term vas deferens. It's an older term that's being dropped. Books now call it the ductus deferens. So in the spermatochore, this is the sperm carrying structure. So I'm going to look at some model photos here. You have one testicular artery, to my knowledge, but here they illustrate many arteries. I don't know if they branch out like that or not, but if it's red, they're going for artery, and if it's blue, they're going for veins. That's simple enough. The vas deferens is kind of hard to spot in here, okay, but it's there. And on this side, it's not fully dissected. They show the cremaster muscle fibers as individual muscle fibers. So all those red lines are cremaster. And the gray layer is the internal spermatic fascia. Okay. Now if you take a close look at this when they cut it open, you can see that it's kind of gray, red, gray. Okay. They're trying to show you all three layers. The internal spermatic fascia, the cremaster, the external spermatic fascia. So those layers are shown on our models. And I did a closer up picture. And I labeled it so you can kind of see the three layers. So it goes gray, red, gray. So you have the internal spermatic fascia, you have the cremaster, and you have the external spermatic fascia. Okay, so there's other models in the room. This model in the room is in one of our cabinets, and I showed you this picture earlier. This is the tunica vaginalis, which is derived from the peritoneum. That's in your notes already. Anyways, it's kind of shown in this model here. So I just tried to find all of the models that show some of these layers. And this one also has a nice muscle layer. That's cremaster muscle going all the way around. Another way to study the spermatochore is in cross-section. And when we do the histology, that is shown here. So I just kind of took a picture years ago when I taught it, and I labeled it for you next to the artwork. Okay. I feel that students should be able to tell arteries from veins. Now, there's one artery, right? And I can always tell an artery, it's usually the larger vessel, and it has a thicker vessel wall. And it's surrounded by many testicular veins. Okay, so like I said, many veins cool down the arterial blood, and you can kind of see that here too. And up here is the ductus deferens, and I can always tell that. I don't know if you can see that little purple splotch of cells. So what will those cells be? The sperm? Yeah. That whole thing is the ductus deferens. There's a lot of smooth muscle that surrounds the epithelial layer in the ductus deferens. So here's a picture by itself. You can even see the cremaster muscle fibers. It's hard to see, they kind of got faded out. I usually don't see it. One other thing that I mentioned is the internal spermatic fascia, connective tissue that kind of surrounds the whole thing there. So we'll study the histology of the ductus deferens. And so that picture, I kind of zoomed in as good as I could, but it was a little blurry. But what I would note is that the ductus deferens has many layers of smooth muscle. It's about 18 inches in length. It's not very long, but if you look at the cross section, many layers of smooth muscle, and also the epithelium is a columnar epithelium. It's a pseudostratified columnar epithelial tissue. I always abbreviated ET. Usually what you'll see, it's hard to see because it's out of focus. You'll see a stereocilia, which will help beat the sperm along with the duct. All right, so let's get down to the scrotum and look at a picture of it dissected open. And what we should learn is that it's not just skin, then testes. There's actually many layers in between before you can get down to the testes. And so this kind of dissects away and separates all the layers for you to learn. So if you go from the outer to inner for the scrotal layers, you have skin, the skin of the scrotum. Okay, remember the scrotum is just an outpouching of the ab cavity for males. You also have right underneath that, look for tunica dartus, this whitish muscle layer. They put a pin between the skin and sub-Q and tunica dartus. That's the next layer I would list. The tunica dartus, it's smooth muscle that gives the scrotal skin that wrinkled appearance. Tunica dartus. So tunic means shirt, means layer. Okay. Now deep to that, we have our three layers that we talked about prior. The external spermatic fascia, cremaster, and internal spermatic fascia. Those are coverings of the spermatochore, but they also surround the scrotal layers as well. So I'm going to list them here. So, external spermatic fascia, cremaster, internal spermatic fascia. And of all these layers, the only one that has kind of some important function is the cremaster muscle. There's something known as the cremasteric reflex, where when that muscle contracts, it draws the testes closer to the ab wall. I mean, it doesn't suck them back into the ab cavity. They're just a little bit closer to the ab wall for warmth. So it's a reflex due to cold temperatures, due to cold, like on a cold day, wading through cold water. Hold testes close. I'll just say closer, okay, just for warmth. Oh, continue with the layers. I think they do show some more. They show this layer here, the tunica vaginalis. Now on the picture, it's good. They kind of show it. They pull it back because it's a double layer. So this is the tunica vaginalis, the parietal layer, the one that's reflected back. But the layer that's right on testes and epididymis is the tunica vaginalis, the visceral layer, and you are responsible to know both. Let me get them down here. Tunica vaginalis. Parietal layer. But also know the visceral layer. It's that whitish coloring. It's kind of right on the testes there. And that's as deep as they go on this picture. But you can go deeper. If you cut all the way through both testes and look at the layers, like, as they number them here, we can number our list on the board. The skin is number 1. The tunica dartos is number 2. And then 3, 4, and 5 are our external spermatic fascia, the cremaster, the internal spermatic fascia. And then they go 6A and 6B for our double layers of tunica vaginalis. So I'll say 6 for tunica vaginalis, but the A and the B are for the parietal and the visceral layer. So, you know, kind of match your notes with the picture, you know, and see if you can name them, you know, without looking. So let me name all the layers here. There's one layer that's deeper after you go tunica vaginalis, visceral layer. This is called the tunica albuginea. It means white, that word right there. Another layer. Functionally, this layer, it's not just a layer that you can peel off, because there's parts of it that invaginate and go into the testes to form these little apartments. So if you can see right here, it's not just a layer that covers, it's a layer that shoots in. And those are called septum. So I'm going to say that the tunica albuginea forms septum. That divide the testes into little compartments. Those little compartments, those contain the seminiferous tubules. Those are the structures that make the sperm. It's something like 1 to 4 seminiferous tubules. Might be a few in there. Now that doesn't sound like too many, but each one of those might be something like 32 inches long. Okay, so that's a lot of convoluted tube to make sperm. Now the testes is associated with the epididymis, shown there. The epididymis is a word that means on top of the twin. Didymis means twin, epi, like an epithelium means overlying. I'll just practice spelling it. Epididymis, M-I-S. Well, there's a head, body, and tail. Now, it doesn't look very long. I mean, the testes is only about that big. However, there's a supercoiled tube inside there, and it's about something like 20 or 21 feet long. About 20 to 21 feet in length. This is a spot, it's continuous with the seminiferous tubules, and it's for sperm storage and maturation. Sperm may develop their ability, what's called motility. They got to move around and swim, right? So if you look at the epididymis, the histology, under a low magnification, if you cut that structure, it looks like a bunch of cut tubes, but it's really just one tube, if you were to stretch it all out. The male duct system is all continuous with each other. And what you can see is that in the lumen of the cut tubes are all the sperm that's being stored. Okay? Now, if you take a closer up look at one of these tubes, this is a 400X, those are the spermatocytes, and you can see the epithelium there. So the epithelium, well, one thing I'll note is that there's no smooth muscle. Like we saw in the vas deferens. So no smooth muscle. And usually I don't write that there's not something there, but I want you to be able to tell epididymis versus vas deferens. So the epithelium is the same. It's a pseudostratified. Columnar. Yeti with stereocilia. So I put the two side by side. You can see they kind of have similar epithelia. They both have sperm in the lumen, but one has smooth muscle and one doesn't. Okay, so that's some of the duct stuff. Let's talk about the penis itself. And I put this picture here to familiarize you with what's called the perineal region, where the penis is. Now, if you read a book, they describe this region as the area between thighs and, buttocks. Region between thighs buttocks. Well, if you look at the picture there, and draw it like this. It's kind of shaped like a bike seat, right? I mean, this is the area that it's on your bike seat, little small ones. And they call this the UG triangle. They call this the anal triangle, even though they didn't draw it as a triangle in this picture. So that's just kind of the name they gave that region. If you look at the picture on the left, if you were to dissect down to the muscle, this kind of is the pubic arch, and there's a muscle that spans the width of the pubic arch called the deep transverse perineal muscle. Okay, and there's a superficial perineal muscle as well. That's kind of the muscle that holds those structures in this region. So associated with this UG triangle, a muscle called deep and superficial transverse perineal. Okay, it's a muscle. And it's important to know for repro, because for ejaculation, you have to move the sperm out of the urethra. So the urethra has to pierce this membrane. And it does so right here. That top little hole for the male. So it pierces the deep one, so I'll put like as a note for the deep. The urethra must pierce this membrane. Find another pen here. And it does. The urethra pierces that membrane. In anatomy, diaphragm means membrane. So sometimes this deep transverse perineal, it's the muscle layer of what's known as the UG diaphragm. So you come across that term. This is the muscle layer of the UG diaphragm. So let me underline all the terms I use. I use the term UG triangle. That just describes this region. However, if you dissect, you'll see that there's a membrane called the UG diaphragm. And the muscle of that membrane or diaphragm is the deep, okay, as well as the superficial transverse perineal. The deep transverse perineal is the significant part of the UG diaphragm. The superficial is just a little band, but it's there, so you should know what it is. And the whole point of you to know it for repro is that the urethra has to pierce it so that the ejaculation can take place. I think I'll stop here. So I'm going to have the test. And so I'm going to break until 9 o'clock, and then you'll have the test right when you come back. So we hit the stop button here. So I want you to